You have a AFK transmitter using a carrier of 500 kHz sending 10 kilobytes per second, a frequency deviation of 100 kHz. How much bandwidth do you need for your transition? The solution for this problem is bandwidth is equals to 2 times frequency deviation plus RB, which is the 2 times 100 kilohertz plus 10 kbps, and our bandwidth is 220 kilohertz. Now let's try answering this problem using the constellation in our right. For the first problem, what type of modulation does this represent? Now, in order to answer this, we need to count all the dots of constellation we have in our right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, we have 16 symbols in our right representing the constellations. Now, let's try writing that. For RA, we have 16 symbols, which represents a 16 PSK. Now for the second part, how many symbols are represented in M? Now, based on the first answer that we counted on the constellation, we knew that there are 16 constellations, so M is equals to 16. Now for the C part, we're going to use the formula n is equals to logarithm of m, which is 16, so logarithm of 16 is equals to 4. Now for the last part, we have a baud rate of 10,000 symbols, and we're going to multiply it with our n, which is 4 bits per symbol, resulting to an answer of 40 kbps. Now we're going to discuss about quadrature phase shift keying, and here is its example model diagram, which has both input Q and I. In QPSK, we both have 4 combinations for both Q and I, which is represented by the logic 0 for negative 1 volts and 1 for positive 1 volts. That will combine with the multiplier. And then, our logics will combine with the reference oscillator, which is negative cosine. Following the format of I, positive and negative, JQ, we'll have I for negative cosine and Q for the negative sign, which is the phase shift. Let's try answering the combination of 0, 0, which is I going to negative cosine. Then we'll have a positive cosine omega ct, and our sign combining with the negative sign, which is negative 1, we'll have positive sine omega ct. And then we're going to use the Pythagorean theorem to find the magnitude of this combination, which is 1 squared plus 1 squared equals square root of 2. Then finding the reference angle using the inverse tangent 1 over 1, we'll have a 45-degree angle. Combining the two results, we're going to have square root of cosine omega ct 45 degrees. Now, based on the phasor angle, we're going to look for where is positive cosine and negative sine, which is in the quadrant 3, which is the negative. And so we're going to add a 90 degrees to the 45 degrees. Then we're going to have it negative since it's in quadrant 3. Next, let's try the combination of 0 and 1, resulting to a negative cosine and a positive sine. Getting the angle will have a result of negative 45 degrees. Based on the phasor, it's in the quadrant 4, which is will retain its negative. Combining all the equations, we'll have square root of 2 cosine omega ct, negative 45. Now let's try answering the combination of 1 and 0, which then will have a result of positive cosine omega ct and negative sine omega ct. Getting the angle, we'll still use inverse tangent, negative 1 over 1, resulting to a negative 45. Now let's try looking where is cosine omega ct and negative sine omega ct, which is quadrant 2, a positive quadrant. Then we'll combine all the answers for a negative square root of 2 cosine omega ct and a positive 135 degrees. Lastly, we'll have a combination of 1 and 1, which is a negative cosine omega ct minus sine omega ct. Still getting the angle, inverse tangent, negative 1 over 1 is 45 degrees, and the magnitude of square root of 2. Looking at the phasor diagram, negative cosine and negative sine is located at a quadrant 1, which is a positive. Combining all the answer, we'll have negative. Creating the phasor diagram, it will look like an X. Let's plot in 0, 1 for the fourth quadrant, and the third quadrant, a QI combination of 0, 0. And for the first quadrant, a combination of 1, 1. And for the second quadrant, a combination of 1, 0. Plotting all constellations will have something like this.